from your statistical classes. So what you do here is that you fix what we call a significance level. Often it's called alpha, and it's often set to 0.05. And you will calculate something that is called the p-value. So it can be a so-called one-tail test, like here, or two-tail tests. And then you will calculate your p-value. So if your p-value falls in this side, so it's lower than your significance level that you've arbitrarily set, then you can conclude that the null hypothesis is true. And here for LCA, the null hypothesis is going to be, because we compare always pairs of alternative. So the null hypothesis will be that the difference between the two scenarios we compare is 0. And if we fall in this zone, we reject. I think I said earlier accept, but I made a mistake, it's reject. So if we fall in this zone, we reject the null hypothesis. So it would mean that no, our scenarios are different. But if the p-value would be greater than the significance level we set, so here we would say, oh, the scenario that we're comparing are actually not different. So we cannot conclude there's significance difference. So I think for LCA, this is very interesting. Now, if I go back to the Excel and I do this here, so yeah, this is their result, and you can see how they did. So they describe it in the paper. And then, yeah, how would you calculate the p-value? You can do that in Excel. So in their case, what they did is that they used the one with two tail that I was telling you earlier. But you can also, so you can calculate it. So it's the student law, but you can also calculate it in another way in Excel. So I did it for fun here in this example. And yeah, you have so I went trying to understand how to do that, and it's quite nice. So here's the step of how to do it. I try to do it again, because then it gives you this little table, and you can yeah, directly see your averages and your standard deviation. So if my memory, and then yeah, and you can also just get the p-value by this function t-test. And of course, you need to do that from many data. So in this case, they did it for the whole Monte Carlo average and standard deviation. Yes, and here the functions, so data was here, and then yeah, you need to install this here, but you can find how to do that online. And then in this case, it's this one, and then you just need to select your variable. You select your alpha level, which is typically 0.05. They discussed that in the paper as well. It's arbitrary, but it's the one typically used. And then I will take the result and just say here. Yeah, and then you get your table as I just had above. So this was a nice discovery. Yes. I think I'm gonna stop there with this. Yes, with this, one thing that you may remember or may not, for some of you, oh yeah, but just one little thing. They have this, they try to make this decision tree to help LCA practitioner to decide which type of uncertainty analysis to use. So it's a really, really nice paper for uncertainties in LCAs. And yes, just for a reminder, with CIMAPRO, you can do Monte Carlo. And the only thing that you need, and I can maybe even show you. The only thing that you need to make a Monte Carlo in CIMAPRO, or in general, it's that you need to inform for each of the parameters that you put on the standard deviation. So it's very important to collect these as you go. And the probability distribution that your data have. That's more difficult. But again, they discuss it in the paper, how to do that. The Ecoinvent database already tells you about the uncertainties of all the background data, so the electricity and so on. They already documented. And you have to remember that they use something called the pedigree matrix for when they don't have an uncertainty on a certain parameter, they try to make one in a quite elegant way. And that's called the pedigree matrix. To know more about it, you can read, of course, this here. If you still see the PDF?
Yes.
Okay. So this is the Ecoinvent tree database documentation. So that's Weidema. And here you have the pedigree matrix. So you will give score. So there is different indicator: reliability, completeness, temporal correlation, yes, geographical correlation, and further technological correlation. Score 1, 2, 3, 4, 5, and they give you different parameter to score. And then according to the value that you get, you apply this formula, and then you get an uncertainty. It's also documented well in this paper of Sirot et al. Or I could also put it on Slack. One thing you have to be careful, so this is one of the latest paper also, and here they say that this pedigree, although it has the merit to be a nice way to document uncertainties when there isn't, because as you know, in LCA, we gather data here and there, so it's not like we make our own experiment and we have our own set of data where we can easily calculate a standard deviation. Sometimes we derive some data, and therefore we cannot really have a standard deviation associated to it. So that's why the pedigree matrix was made. But here what they figure out is that doesn't go too well with Monte Carlo, and they actually don't recommend. If you have too many of your data that are based on the pedigree, so too many of your uncertainties, based on the pedigree matrix, they say that your Monte Carlo will just give you nonsense. And Patrick experimented that. So when he tried to do it with CIMAPRO, it was just saying that, okay, it gives nonsense now. There's just too many uncertainties. So I don't know if you see CIMAPRO now.
Yeah, I see the CIMAPRO.
Good. So I just took a random process. So as I say, you see that, okay, you have your amount documented, the distribution, and then the standard deviation. And then let's say you would want to do, of course, you would do it on your final assembly, but I don't have example of assembly on this database. So let's say that you want to make a Monte Carlo, you just need to click this here, uncertainty analysis. And you have this that appears just as when you want to analyze data. And then you can fix your number of run, and that's it. You can just go. So it's quite, easy to do it in CIMAPRO. The Monte Carlo analysis, it's no big deal here. Yes. So I'm stopping here because now it's been a little while, but I thought this was a very good reminder about uncertainty in LCA. And many LCA don't do it properly. And even many of my LCAs don't include uncertainty properly. But this is quite important very often to be able to conclude between scenarios. So I really encourage you right now, for those that are starting their LCAs, so that's BLA, that's ZOO, to also gather, and that's Shivesh as well, gather information on the standard deviation of each of your values. Yes.